In this video, we'll take the part 2, the statistics and machine learning, that is the inferential statistics. The very important concept is the hypothesis test, statistical hypothesis test, how to compare two samples. And we want to interpret the data assuming a specific outcome. The statistical method will tell us whether to confirm or reject the assumption. The assumption is called hypothesis, and the statistical tests used for this purpose is called statistical hypothesis tests. The assumption of the statistical test is called the null hypothesis, H0 in short, or a default assumption. A violation of the test's assumption is often referred as the first hypothesis, H1. So there's two hypotheses, H0 and H1. The H1 is the assumption of the test which does not hold and is rejected at some level of significance. So what is level of significance? So interpreting the result of a statistical hypothesis using a p-value, which is the probability of observing the data given the null hypothesis is true. A large probability means H0 or the default assumption is likely. A small probability value less than 5% suggests that it is not likely that we can reject the H0, and favor H1. So widely used statistical hypothesis tests such as student's t-test are used for comparing the mean values from two independent samples. Thus we can see the null hypothesis plays a very important role in testing the significance of difference in samples. The usual null hypothesis of an experiment is that there are no differences between the samples. The standard level of significance used to claim the statistical significant effect is taken in general as 0.05. So p-value is 0.05. If the p-value is near 0, the associated null hypothesis remains doubtful. If the p-value is from 0.1 to 0.9, there is certainly no reason to suspect the hypothesis tested. Where it is used, like in the baseline model, we can predict the mean outcome value for the regression problem. We can predict the class for a classification problem, or we can predict the input as the output for the forecasting problem. So comparing the performance of the machine learning models for the specific data to the models also trained on the same data, we can use the tools for statistical significance test. See whether our model outperforms the baseline or not. A statistical test called Z-score, it computes the probability of the hypothesis and hence decide with a given level of confidence whether to reject or not to reject the null hypothesis. So this Z value, the Z-score, it expresses the number of standard deviations that lie between the mean of a population and the value of a data point. The more the standard deviations from the predicted mean, the less likely it is that the estimate could have occurred under the null hypothesis. So thus the Z-score value helps us in accepting or rejecting the null hypothesis. Coming to the significance level alpha, this evidence is sufficiently strong to state that the population's mean is higher than 25 in this particular example, where the population mean of the exam is being 25, and after selecting a sample of 30 students, it turns out that the average mark is say 28. So whether this evidence is sufficiently strong to state that the population's mean is higher than 25, so we assume that the mean is 25 and the alternative hypothesis, that is H1, is greater than 25. By setting the significance level, which is a margin of error, we can reject the null hypothesis. So the distribution is symmetric, so we'll have two critical values of Z-score, boundary, which are at the boundary of the acceptance area. We'll see in one of the diagram where the green is the acceptance area and the red represents the rejection area. This is a formula for the Z-score. Since the Z-score, if it falls out of the acceptance area, we can reject our null hypothesis. So this is the green area which is the acceptance area, and the tails, both the tails, the 0.025, that adds up to 0.05, that is the area where we do not accept, we reject it. So if the p-value is less than the significance level, we can reject the null hypothesis. This will leave in a tail the probability of 2.5% for each side. There is another test called ANOVA, analysis of variance, where again a significant value plays an important role to reject or accept the hypothesis. Here we can see one example where grading the source of variability. H is highly significant where p is less than 0.05, medium significant where p is 0.05 to 0.1, n is for not significant where p value is greater than 1. This has been used in one of the research area where the visual interpretation of the texture has been characterized using the analysis of variance by categorizing them into toned, row significant and column significant or diagonally oriented texture. So given the texture tonal mix, using the inferential statistics, suppose the ANOVA, the texture tonal orientation present in the image. The analysis of variance is related to the variance of the samples. So variance between the groups, variation within the groups. We can see two types of variation, within the group and between the group. Using the two-way ANOVA, there is two-way ANOVA tests and three-way ANOVA tests. This is a two-way ANOVA tests. We are conducted for the presence of two source of variability, that is the row effect and the column effect. This is the formula for the two-way ANOVA with replication, and we get three types of effects. That is the main effect for the factor A, here it is row, main effect for the factor B, which is column, or is there any interaction between the row and the column. For the two-way ANOVA, we get three null hypotheses. First factor effect at different levels are same. Second null hypothesis, second factor effects at the different levels are the same. And the third hypothesis, there is no interaction among both the factors. So the texture characterization using the inferential statistics was done using the progressive sampling. So given this image, whether it is column significant or row significant, or is there no relation between the row and the column, can be, these are some of the hypotheses, and this has been found out by using this inferential statistics. The paper has proposed a progressive sampling to represent a true representation of the population, and used three types of control parameters: gap pixels, inside region pixels, sampling average, so that the sampling purpose the sampling is well done for ANOVA grading analysis. So this is a progressive sampling. The red dots you can see from the image it has taken. It generated a string code representation which consists of the characters N, M and H depending on the statistical significant effect of the rows and the columns. This is the ANOVA grading. No grade, interaction specific, column specific, row and column specific. This is column specific, this is row specific, this is row specific, and row and column specific. So by characterizing the textures using the ANOVA analysis, and depending on the significant value, the hypothesis, whether it is row specific or a column specific or interaction specific. The statistics in various stages of ML. For data preparation, the statistical methods used outlier detection, missing value imputation, data sampling, data scaling, variable encoding. When the model has to be evaluated, then the evaluation very much depends on the data sampling, data resampling, experimental design. Which model to select depends on the data sets, the data categories, and the problem statement. You can use the appropriate statistical hypothesis tests, significant difference between the results, quantifying the size of the difference between the results. Coming to the model representation, the estimation statistics, confidence levels, summarization of the skill on average, and expected variability in practice is used for the model presentation. Coming to the prediction, the estimation statistics, prediction intervals, expected variability in prediction can be used for the prediction purpose. In the data preparation, we have mentioned just now the outlier detection, sampling, scaling, and variable encoding. What is an outlier? So the standard deviation will help in identifying the outliers. It affects the mean value of the data. Scaling and normalizing are very important process for the data pre-processing, where you can use from the sklearn pre-processing package. The standard scalar function is used, and it is the function called as fit transform. So the raw data is scaled and normalized. Variable encoding, most of the time the machine learning algorithms cannot handle the categorical variables unless they are converted to the numerical values. So the categorical variables can be identified, divided into two categories, the nominal and the ordinal. The three popular techniques are integer encoding, one-hot encoding, learned embedding. The machine learning libraries used from the scikit-learn are ordinal encoder. Also, it provides label encoder. The learned embedding, also referred as a word embedding, it provides a distributed representation of the words in terms of the vectors. It's used by the Keras functional API for the deep learning. The function, the package is the Keras layers, where you have to import the embedding. So what type of encoding is best is not known. You have to perform on the different data sets to find out the answer. Tools for statistical significance tests. The samples drawn from the same population are similar, then there's no difference between the model skills is assumed. So these tools will estimate the likelihood that the two samples are drawn from the same or different distribution of the model skill scores. How to handle a non-parametric statistical method? What are the non-parametric statistical method? When for a particular distribution we know the mean and the standard deviation, then it is a parametric. Beforehand, before using the machine learning, we are aware of the distribution of the data set. In case we do not know the distribution, then for such non-parametric statistical method can be applied, where the data is converted into a rank format, and sometimes it's called the rank statistics, rank correlation, rank statistical hypothesis tests are used. So conclusion, prediction is less robust to departures from the normality when there is a high standard deviation, and the distinction between the variability and the uncertainty is useful in understanding the distinction between the confidence intervals for the conditional mean and the prediction intervals. So to measure the degree of uncertainty in our estimate for the conditional mean, prediction interval must also take into account the variability in the conditional distribution. So the objectives met in this particular two parts of the statistical analysis for machine learning. We came across two types of statistics. One is the descriptive, another is the inferential. Then we talked about the Gaussian distribution, knowing the mean and the standard deviation. Then how to quantify the relationship between the two samples between two sources, and how to check the differences between the two samples using statistical hypothesis test. What is the H0? What is H1? What is null hypothesis or the alternative hypothesis? What is the significance value, that is the p-value, the estimation statistics, and how non-parametric methods can be used when the data is not drawn from the Gaussian distribution. And couple of theorems we have discussed, that is the central limit theorem and the law of large numbers. These are the references. Thank you.